Hi, this is Alex from devstories.eu, learning dspy, episode 15 of 15. What happens when you combine Bayesian prompt optimization with deep learning weight fine-tuning? You stop treating prompt engineering and model training as isolated steps, and you start treating them as a continuous pipeline. This is where you reach the cutting edge of automated AI engineering, relying on ensembles and meta-optimization. We need to clear something up immediately. When you hear the word ensemble, you probably think of querying 5 different foundation models simultaneously. In dspy, an ensemble is something else entirely. An ensemble here means running multiple optimized programs on the same underlying language model. It combines different prompt structures and different reasoning traces to aggregate their outputs. The logic here is straightforward. During a deep optimization run, different configurations often discover distinct, equally valid reasoning paths to arrive at the correct answer. Say you just ran the myprov2 optimizer. It evaluates hundreds of configurations and keeps a history of the best performers. Instead of picking the single highest scoring program and discarding the rest, you extract the top 5 candidate programs. You pass these into the dspy ensemble transformation. When a new input comes in, the ensemble executes all 5 programs. It aggregates their outputs, usually through majority voting, and returns a final, highly robust answer. You are essentially scaling your compute at inference time to guarantee a higher quality result. Running a 5-program ensemble on a massive foundation model gives you incredible accuracy, but it is expensive and slow. This is where meta-optimizers come in. A meta-optimizer manages the execution of other optimizers, sequencing them to compound their benefits. The prime example in dspy is BetterTogether. BetterTogether layers improvements systematically. It allows you to take the massive reasoning capability of your ensemble and distill it down to a fast, fine-tuned model. First, you configure BetterTogether to use prompt optimization to generate extremely high-quality reasoning traces from your heavy ensemble. Next, it automatically passes those traces into a weight optimizer. The weight optimizer uses that data to fine-tune the parameters of a much smaller, cheaper student model. Finally, BetterTogether can run a second round of prompt optimization, this time tailoring the instructions specifically to the newly updated weights of the student model. You are moving from prompt optimization to weight optimization back to prompt optimization. The output is a highly specialized, fast model that captured the diverse reasoning paths of the original ensemble without the massive inference cost. Layering optimization techniques sequentially is how you bridge the gap between heavy, expensive reasoning and fast, production-ready inference. This brings us to the end of the series. I highly encourage you to explore the official dspy documentation, try building these pipelines hands-on, or visit devstories.eu to suggest topics you want to see covered next. Thanks for listening. Happy coding, everyone.